If the service specifications indicate an input voltage range of 100 to 127 volts for the low range and 200 to 240 volts for the high range, selecting the right connection hinges on the supply voltage you have available. For a 240 volt supply, the recommendation is to utilize the high range, specifically the 200 to 240 volts input. Regarding the outlet type for a high-range connection of 200 to 240 volts, a 4-pin outlet is required. This type of 240 volts outlet typically provides 3 conductors consisting of 2 hot wires and a neutral wire alongside a ground wire. In contrast, for a low-range connection of 100 to 127 volts, a 3-pin outlet is required. This 120 volts outlet provides 2 conductors, 1 hot wire and a neutral wire, plus a ground wire. It's important to note that using a 3-pin outlet for a 240 volts connection is not recommended. This could result in insufficient voltage and potentially damage the server equipment. It is crucial to adhere to the server's voltage specifications to ensure proper operation and prevent damage. The selection of the appropriate outlet, whether 3-pin or 4-pin, is directly linked to the voltage range being used. Always verify the server's power requirements and the available supply voltage before making any connections. Firstly, understanding the server's power input requirements is crucial. The server's documentation or label on the device itself should clearly state the acceptable input voltage range. This range might be specified as a single voltage, such as 120 volts, or a range such as 100 to 127 volts or 200 to 240 volts. Servers often have power supplies that can operate within a certain voltage range, offering flexibility in different power environments. Secondly, determine the available supply voltage. Before connecting the server, identify the voltage of the power source you'll be using. In North America, standard voltages are typically 120 volts for residential outlets and 208 or 240 volts for higher power applications. In other regions, 230 volts is common. Using a multimeter to measure the voltage at the outlet can confirm the supply voltage if there's any uncertainty. Thirdly, match the server's voltage requirement with the supply voltage. If the server's input voltage range matches the available supply voltage, you can proceed with the connection. If the server has a switch or configuration setting to select the input voltage range, ensure it's set correctly. For example, some servers have a switch to select between 110 to 120 volts and 220 to 240 volts. Fourthly, regarding outlet configurations, understand the differences between 3-pin and 4-pin outlets. A 3-pin outlet typically has 2 vertical slots and a round ground pin. This configuration is common for 120 volt circuits. The 2 vertical slots are for the hot wire and the neutral wire, while the round pin is for grounding. A 4-pin outlet, on the other hand, has 2 vertical slots, a horizontal slot, and a round ground pin. This configuration is generally used for 240 volt circuits. The 2 vertical slots are for the 2 hot wires, the horizontal slot is for the neutral wire, and the round pin is for grounding. Fifthly, connect the server to the appropriate outlet. If the server requires 120 volts and the available outlet is a standard 3-pin outlet, you can connect the server directly. If the server requires 240 volts and the available outlet is a 4-pin outlet, you'll need a power cord with the correct plug configuration. Ensure the plug matches the outlet and the server's power input connector. Sixthly, avoid using adapters or extension cords improperly. Using adapters or extension cords to connect a server to an incompatible outlet can be dangerous and may damage the equipment. If a server requires 240 volts but only a 120 volts outlet is available, do not use an adapter to try to convert the voltage. Instead, have a qualified electrician install a dedicated 240 volt circuit with the appropriate outlet. Seventhly, consider grounding and surge protection. Proper grounding is essential for the safe operation of servers and other electronic equipment. Ensure the outlet is properly grounded to prevent electrical shocks and reduce the risk of damage from power surges. Using a surge protector can also help protect the server from voltage spikes and other power disturbances. Eighthly, Pay attention to the neutral connection. In a 4-pin outlet, the neutral wire provides a return path for the current. It's essential to have a proper neutral connection to ensure the circuit functions correctly. A missing or faulty neutral connection can cause voltage imbalances and may damage the equipment. Ninthly, hire a qualified electrician for high voltage connections. If you are working with 240 volt circuits or higher, it's always best to hire a qualified electrician to handle the installation. Working with high voltage electricity can be dangerous, and an electrician has the knowledge and experience to ensure the job is done safely and correctly. 10thly, always double check and verify your work. Before powering on the server, double check all connections to ensure they are secure and correct. Verify that the voltage settings on the server and the outlet match. If you're unsure about anything, consult the server's documentation or seek assistance from a qualified electrician. Following these steps will help you safely and correctly connect a server to a power source, ensuring reliable operation and preventing damage to the equipment. Remember, electricity can be dangerous, so always take precautions and consult with a professional if needed. Understanding the nuances of server power connections, especially regarding voltage ranges and outlet types, is critical for ensuring the reliable operation of your equipment. Servers, unlike many consumer electronics, often have specific power requirements that must be met to prevent damage and ensure optimal performance. When a server's specifications indicate an input voltage range, such as 100 to 127 volts for a low range and 200 to 240 volts for a high range, the selection of the appropriate connection type becomes paramount. This decision isn't arbitrary, it directly affects the server's ability to function correctly and safely. Firstly, let's delve into the implications of a 240 volt supply. If your available power source is 240 volts, the recommended course of action is to utilize the server's high range input, which is specified as 200 to 240 volts. This range is designed to accommodate the 240 volt supply, ensuring that the server receives the correct voltage for its internal component. Attempting to use the lower range input with a 240 volt supply would likely result in damage to the server's power supply unit or other sensitive components. Secondly, the outlet type is closely linked to the voltage range. For a high range connection of 200 to 240 volts, a 4-pin outlet is typically required. This type of outlet, often referred to as an M14-30 or an M14-50, is designed to provide the necessary conductors for a 240 volt circuit. It includes 2 hot wires, a neutral wire, and a ground wire. The 2 hot wires carry the electrical current, the neutral wire provides the return path for the current, and the ground wire serves as a safety measure to protect against electrical shocks. Thirdly, understanding the role of each pin in the 4-pin outlet is crucial. The 2 hot wires, typically labeled LONE and L2, each carry 120 volts relative to the neutral wire. When combined, they provide a 240 volts potential difference. The neutral wire, labeled N, provides a return path for the current and is typically grounded at the service panel. The ground wire, labeled G, is connected to the earth and provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shocks. Fourthly, the 3-pin outlet, on the other hand, is commonly used for 120 volt circuits. It typically has 2 vertical slots and a round ground pin. One vertical slot is for the hot wire, which carries the electrical current, and the other vertical slot is for the neutral wire, which provides a return path for the current. The round pin is for grounding. Fifthly, using a 3-pin outlet for a 240 volts connection is strongly discouraged. This is because a 3-pin outlet is not designed to handle the higher voltage and current of a 240 volt circuit. Attempting to connect a 240 volts device to a 3-pin outlet could result in overheating, electrical shocks, and damage to the equipment. Sixthly, the consequences of using the wrong outlet type can be severe. If a 240 volt server is connected to a 120 volts outlet, the server may not power on at all, or it may operate erratically. If a 120 volt server is connected to a 240 volts outlet, the server's power supply may be damaged or destroyed. In either case, the server may require repair or replacement, resulting in downtime and additional costs. Seventhly, verifying the server's power requirements is essential. Before connecting any server to a power source, always verify the server's power requirements. This information can typically be found on a label on the server itself or in the server's documentation. The label should indicate the acceptable input voltage range, the power consumption in watts or amps, and the type of outlet required. Eighthly, consulting with a qualified electrician is always a good idea. If you are unsure about any aspect of server power connections, it is always best to consult with a qualified electrician. An electrician can assess your power needs, ensure that your electrical system is properly configured, and safely connect your servers to the appropriate power sources. Ninthly, remember that electrical safety is paramount. Working with electricity can be dangerous, so it is essential to take precautions. Always disconnect the power before working on any electrical equipment, and never work on electrical equipment while standing in water or on a wet surface. If you are not comfortable working with electricity, hire a qualified electrician to do the job for you. Tenthly, double check and confirm the proper connection. Before powering on the server, double check to ensure that the outlet and server voltage requirements match. Ensure that the server is plugged into the appropriate outlet and that all connections are secure. Powering on a server without verifying these details can lead to equipment damage or present a safety hazard. By understanding the voltage requirements, outlet types, and safety considerations involved in server power connections, you can ensure the reliable and safe operation of your server equipment.